Alright everybody, today we're going to be talking about the focus and directrix of a parabola. Going into this, you want to have a good foundational knowledge of the vertex form for parabolas, not only vertical parabolas, but horizontal ones as well, for parabolas that open sideways, left or right. So let's get into it. Let's start talking about what the focus and directrix is and how we can go about finding the answer to some of these questions, how to find the focus or directrix on some of these parabolas. So a parabola is a set of all points in a plane that are equal distance from both a fixed point called the focus and a fixed line called directrix. So this is the important part of it. An equal distance from both a fixed point called the focus and a fixed point called, or fixed line called the directrix. So you can see on my screen here a parabola. You can see where the vertex is. Here you can see where the focus is and where the directrix is. Directrix is this line down there. So what basically our theorem here says is that every single point on our parabola, whether it be the ones that they've already shown you here, P1 and P2, every single one of these points is going to be equal distance from the focus as it is from the directrix. So this dotted line here is the same distance as this dotted line here. And that goes for any point. It goes for P2. P2, its distance from the focus is going to be equal to its distance from the directrix. And you can find any point you want. It can be way up here, it can be way down here. It's always going to be the same distance to the focus as it is to the directrix. Which is kind of neat. That information is particularly useful to people who make satellite dishes. Satellite dishes use this to sort of centralize the signal or beam of light to a certain focal point. And in the main part of the information you really want to take away of this is that they're equal distance from each other. So we're going to have a couple types of problems today. We're going to look for basically where is the focus and where is the directrix. If we know one or the other, we're going to find the distance between them. We're going to write the equation of the lines, or not the equation of the parabola, given the fact that we know the focus and directrix. All right. So just a couple examples so you kind of get the idea. And the main thing that you should really understand about focus and directrix. So on this parabola, you want to note that the vertex here, all right, obviously its distance to the focus has to be the same distance to the directrix. This bit of information from the vertex is going to be the key source of a lot of information we're going to be working with today. We talked about in the previous video how to find the vertex, given the vertex form of an equation. And if we know where the focus is and the vertex, we can use that information to find out where the directrix is going to lie. Because I'll know if the focus, let's say, is 1 unit above the vertex, that means the directrix is 1 unit below the vertex. So we can sort of use that power to help us find either focus or directrix given one piece of information or the other. So same thing on this one, you can see the focus. Notice, okay, where it is. It's 2 points or 2 units above the vertex, which means the directrix would be 2 units below the vertex. Because they have to be the same distance. That key piece of information, that has to, if that's 2 units long from the vertex to the focus, then it has to be 2 units long from the focus to the directrix. So again, that information is very powerful to us. We can use that information knowing that it's going to be equal distance to find one or the other. Alright, and another example. This one opens sideways, but it's still the same principle. Our focus, notice where it is here at 5, 3. If, let's say, I know the directrix is x equal to 3, right? Well, I know the directrix is 2 units away from the vertex, so that must mean the focus is 2 units away from the vertex, but in the other direction. So again, that equal distance information is going to come quite in handy, knowing that. So let's just practice a few that's halfway filled in for us. So these 2 examples, I put together these graphs and I gave you the equations. You might want to pay close attention to the equations in the future when you don't see your graph, because we're going to be able to use the information from just the equation, not even looking at the graph, to answer the same type of question. All right, so our focus is at 0, 2. So if it's about here, right, that's my focus. Now, if that's where my focus is, where is my directrix is the question. Well, again, if I know that the focus is 2 units above the vertex, that means the directrix is going to be 2 units below the vertex. So the directrix is going to be right here. And we're going to write the equation for that line. That's the line y equals -2. So it's at -2. We're writing the equation y equals -2 because it is at -2 on the y-axis. All right, let's move over to the other one. Now this one opens sideways. It's a horizontal shaped parabola. All right, and it says its focus is at 4, 0. So its focus is right here at 4, 0. And I need to find the directrix. Well, using that information, knowing that this is 4 units away from the vertex, must mean the directrix is 4 units away from the vertex. So the directrix is going to be here. That's where the direction is going to go. Notice I'm drawing it up and down because, or vertically, because the parabola is facing sideways. So there it is, and that's the equation x equals -4. So it's x equals this time because we're on the x-axis equal to -4, hence x equals -4 is the equation of our directrix, or the line of our directrix. All right, so again, use that information. If we know where the vertex is, which is why we talked so much yesterday in the previous video, about why we spent all that time finding what the vertex was, because we know where that is, and we know where either the focus or directrix is, we'll be able to basically figure out everything about this parabola. So let's try 2 more. Now this one, it doesn't tell us the focus, but it does tell us the directrix. So here's the equation for the parabola that's being shown right here. If you're backtracking to yesterday, you would note that the vertex, this would be the k value, is a +3, and this would be my h value is a +4, because remember these signs are opposites for both the -3 and -4. So that means the vertex of this line would be at the point 4, 3, which you can see it is 4, 3 roughly. You can't really tell too much, but it is there. Keep that in mind because, and like I said, in future questions we're going to be given these parabolas, but we're not going to be given them as graphs, so we're going to need to remember how to find the vertex by hand. All right, but anyway, the directrix is at y equals 0, so that's the line right there. Y equals 0. It's on the y-axis. It's at y equals 0. All right. Now I want to find focus. Well, let's see. How far away was the directrix from the vertex? It was 3 units away from the vertex. So now if I want to find the focus, I got to go 3 units upwards. So focus is going to be right here. And what is that ordered pair? That pair is going to be the point 4 on the x-axis and 6 on the y-axis. So the focus is at the point 4, 6. All right, I'm going to try just one more. Again, you can already see the parabola graph, but if it wasn't graphed, what is the vertex just given the equation? Well, the h is equal to a -1, the k is equal to a -2. So the vertex would be the point -1, -2, which you can see. -1, -2, the vertex is right about there. Okay, and the graph's kind of iffy on my scale, but it's there. All right, anyway, moving on. The directrix is that x equals -2. So x equals -2, that's the line that's going to go vertically right here at -2 on the x-axis. And how far away is that line from the vertex? Well, it's only 1 unit away. So it means the focus is 1 unit away. The focus is going to be right here at the point 0, -2.